From skyscrapers designed by civil engineers to the seating arrangement in a cinema theater, coordinate geometry is used. Cartesian system is to locate the position of an object on a plane uniquely. It is named after René Descartes, who brought out this idea introducing coordinate geometry. A Cartesian plane is formed when horizontal number line x-x and vertical number line y-y intersect at their zeros, which is marked as O for origin, and thus dividing them into 4 quadrants. Also, x-x and y-y are called as x-axis and y-axis respectively. Every point has unique coordinates expressed in brackets, with the x-coordinate or the abscissa first and then the y-coordinate or ordinate, where the abscissa is the distance of the point from the y-axis and the ordinate is the distance of a point from the x-axis. The coordinates of a point on the x-axis are of the form x0 and on the y-axis are of the form 0y. Also, the coordinates of the origin are 0, 0. Now that we have understood about locating points in the Cartesian plane, what about finding the distance between these points? Let's check it out. Suppose to go to your friend's house, you need to walk 12 meters to the east and then 14 meters to the north. But can you say what is the shortest distance between the two houses? Considering the houses as points A and B respectively, by Pythagoras theorem, the length AB will be root of AC square plus BC square, which is root of 12 square plus 14 square, that is 17.69 meters. In a similar way, by using Pythagoras theorem, we can find the distance between any two points in the Cartesian plane. For example, here we have 2 points with coordinates 3, 2 and -4, 3 marked as P and Q respectively. Now draw perpendiculars PR to the y-axis and QS to the x-axis, where coordinates of R will be 0, 2 and S will be -4, 0. Then extend QS and PR such that they meet at T, whose coordinates are -4, 2. So to find the distance PQ, you need to know the distance of PT and QT. PT is PR plus RT and QT is QS plus ST. Since P is 3 units away from the y-axis, PR equals 3 units. And since Q is 3 units away from the x-axis, QS equals 3 units. Similarly, since T is 4 units away from the y-axis and 2 units away from the x-axis, RT equals 4 units and ST equals 2 units. So PT equals 7 units and QT equals 5 units. Now we can find PQ by Pythagoras theorem. PQ equals root of PT square plus QT square, that is root of 7 square plus 5 square, which is 8.602 units. Now let's try to produce a direct formula to find the distance between 2 points if the coordinates were given. Have you noticed any relation between the values of PT and QT with the coordinates of P and Q? PT is the difference between the x coordinates and QT is the difference between the y coordinates. So now we know how we can formulate the distance between any 2 points. Let there be 2 points, say P and Q, on the xy plane with coordinates x1, y1 and x2, y2 respectively. To find the distance PQ, we first draw PR and QS perpendicular to the x-axis and a perpendicular from the point Q on PR is drawn to meet it at the point T. This is now a right angled triangle. So by Pythagoras theorem, PQ equals root of PT square plus QT square. That is, PQ equals root of x2 minus x1 whole square plus y2 minus y1 whole square. This formula is called as distance formula. This formula can also be written as PQ equals root of x1 minus x2 whole square plus y1 minus y2 whole square. This is because even though we get a negative value for PT or QT, it is squared to become a positive value. Suppose one of the points is the origin, that is with coordinates 0, 0, then the distance of a point PXY from the origin will be OP equals root of x square plus y square. Now that we know the distance formula, even without drawing the xy plane, we can find the distance between two coordinate points. Let's try that by working out a couple of problems. Find the distance between the coordinate points minus 5, 7 and minus 1, 3. Here x1, y1 equals minus 5, 7 and x2, y2 equals minus 1, 3. Using distance formula, the distance will be root of x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the values in the formula, we get the distance as root of minus 1 minus 5 whole square plus 3 minus 7 whole square. Upon further simplification, we will get it as root 32. By factorization, we get root 32 equals 4 root 2, which is the distance between the coordinate points minus 5, 7 and minus 1, 3. The next one is check whether A 7, 10, B minus 2, 5 and C 3 minus 4 are collinear. If not, then check what type of triangle it forms. If these points are collinear, then the sum of the two sides must be equal to the third side. Otherwise, it's a triangle. So, let's first find the distance of each side. Using distance formula, root of x2 minus x1 whole square plus y2 minus y1 whole square, we can write AB equals root of minus 2 minus 7 whole square plus 5 minus 10 whole square. BC equals root of 3 minus 2 whole square plus minus 4 minus 5 whole square. And AC equals root of 3 minus 7 whole square plus minus 4 minus 10 whole square. On further calculation, we get AB and BC as root 106 and AC equals 2 root 53. Adding the smaller lengths AB and BC, we get 2 into root 106, which is not equal to AC, that is 2 root 53. So the points A, B and C are not collinear and forms a triangle. Since AB equals BC, triangle ABC is an isosceles triangle. Now we need to check if this triangle is a right angle triangle. For that, we use Pythagoras theorem. AB square plus BC square equals root of 106 square plus root of 106 square, which is 212, and it is equal to AC square. So triangle ABC is an isosceles right angled triangle. So we can conclude that the formula for the distance between two coordinate points P x1 y1 and Q x2 y2 is root of x2 minus x1 whole square plus y2 minus y1 whole square, and if one of the points is the origin, then the formula is OP equals root of x square plus y square.